confusion here on the Comet ISON Parallax video I did last. We're going to take a look here first at the individual exposures that made up the stacked image. So you can see in each exposure there's just one nucleus, which forms a line in all of the exposures. The coma and the nucleus are indeed visible in all of the individual exposures, but there's only one nucleus, one coma, one tail in each of the exposures. And when it makes that sharp turn, if you actually look at the full scale of the image, you can see that it is still a line. It's a shortened line, but it's a line nonetheless with a bend to it. And so when you stack all those images together, here's what you get. You can see what looks like 5 objects, but it's from 5 different exposures stacked together. The stacking is done with the stars aligned, and so the comet, which moves, forms a series of dashed lines, each dash representing one of the exposures. You can also see that the coma and the tail actually do exhibit parallax as well. If we look at, say, the first image and compare it to the stack, you can see the coma and tail is much thicker, much bigger than in just the individual image. In fact, if you look, you can clearly see the coma here is moved up, just as it did in the exposures. Okay, so the coma and the tail are exhibiting parallax as well. And it might be easier to visualize this whole process if we look at it from the opposite direction. So if we take Celestia and put our camera at the position of Comet ISON and look back towards Hubble during the orbit where it took these pictures, here's what we see. Now you can see I trace out the line of Hubble's motion over that period of time, and it forms the same bend. It makes more sense now, though, doesn't it? Because you can see Hubble orbiting Earth. Earth is moving relative to ISON. Hubble is moving with Earth, but Hubble's also orbiting Earth. And if you overlay all these motions, you can see that it does indeed form the same angle that we saw in the comet's motion. That's all that's really happening here. This is the parallax occurring from Hubble orbiting Earth. If you were at a stationary point on Earth and watching ISON, say right about here, sorry it moves kind of fast, but you can kind of see it would form a straight line if you were just a stationary observer on Earth. But Hubble is not a stationary observer on Earth, and it's orbiting Earth, and so you see parallax, which deflects the line formed by the comet. So that's that. Hi folks, just going to clear up a couple quick points of confusion here on the Comet ISON Parallax video I did last. We're going to take a look here first at the individual exposures that made up the stacked image. So you can see in each exposure there's just one nucleus, which forms a line in all of the exposures.